Okay, so now let's discuss joint variation. So what is a joint variation? On our previous discussion, we said that this is similar to direct variation. The only difference is that it has two or more quantities involved. So take note of our statement: A varies jointly as B and C. Means A is equal to K, the constant of variation, B and C. So if you're going to solve for K, that is equal to A over B, C. So let me rewrite the equation. So the equation now is A is equal to the constant of variation, so it varies jointly with B and C. Now you are asked to solve for K. So how did we come up with this equation? So simply, since we have to isolate K, we divide both sides by BC so that this will be equal to 1. So a quantity divided to itself is 1. So 1 times K is K. So by symmetric property, that would be K is equal to A over K is equal to A over BC. So that is your equation of the constant of variation. So let us take some examples. Find the equation of variation where A varies jointly as B and C, and A is equal to 36 when B is 6. So let us first have this one. The statement says that A varies jointly as B and C. So do not forget to write your constant of variation. C. A is 36, B is 3, and C is 4. So let us solve this as this one. We use this equation. So let us substitute A is 36. So I'll be having 36 is equal to K. What is the value of your B? 3. So times 3 times C, which is 4. Okay, so let me simplify first this part. 3 times 4 is 12, and 12 times K is 12K. Now we are going to solve for K, so we have to isolate that one. We divide both sides by 12. So 12 divided by 12 is 1, so that would be K. And 36 divided by 12 is 3. So the value of your K now is equal to 3. So the equation of your variation, so we go back to this equation, your A now is equal to, your K is 3, BC. We simply substitute the value of K to the original equation that we have. Okay, let us continue. Z varies jointly as X and Y, and Z is 62 when K is equal to, when X is equal to 5 and Y is equal to 6. So the first step that we have to do is to write your equation. So Z varies jointly as X and Y. So I'll be having Z is equal to K. Do not forget that varies jointly as X and Y. X and Y. Now, Z is 62, so I'll substitute that is equal to K. So I'll be rewriting K. X is 5, so that would be times 5. And Y is 6. Okay, so we simplify. 5 times 6 is 30. Okay, 30 times K is 30K, 62. So we have to isolate K. We divide both sides by 30. Okay, so 30 divided by 30 is 1. 1 times K is K. Now, 62 cannot be divided to 30, but we can rewrite that into its simplest form. So what are we going to do? We simplify. So let us divide both numerator and denominator by 2. 62 divided by 2 is 31, while 30 divided by 2 is 15. So your k now is equal to 31 over 52. So the constant of variation is 31 over 15. So I'll be writing the equation z is equal to 31 over 15. What is your x? X, y. Now we solve the following equation by using this values. So we find z when x is 7 and y is 8. So let us start with this one. So we find z. So the equation is already solving in terms of z. So z now is equal to, so 31, let us have the value of x is 7 and your y is 8. So all over 15. So we are going to multiply. What is 31 times 7 times 8? So that is 31 times 7 times 8. That is 1,736. 1,736. The question now is that can we divide it by 15? Is it divisible by 15? No. So we can simply simplify that. So let us try to divide it by 3. 1,736 divided by 3. Is it possible? No. It is not divisible by 3, and this is not divisible by, though 15 is divisible by 3. So if there's no more number divisible to both, we can say that z is 1,736 divided by 15, or all over 15. So that is your final answer. Now, how about B? So let me just erase some part of this. Okay, let's delete that one. So, okay. So let us solve B. 31 over 15. So z, again, I'll be rewriting the equation. 31 over 15 xy. Now, we are going to solve for x when z is 72 and y is 4. So I'll be having z, so substituting now, that is 72, is equal to 31. So I'll be having here x, we find x, and you have y is equal to 4, we substitute it by 4. So all over 15. So we simplify the numerator, or we can now get the cross product. The denominator of this one is 1. So 31 times 1. So that would be 31 times x times 4 is equal to 72. When you cross multiply, 72 times 15. So let us now multiply. So what is 31 times 4? So we multiply that. So let me just enclose this in a parenthesis. So 31 times 4 is 124 times x. So that is 124 x equals 72 times 15. That is 1080. 1080. So next, okay, we divide both sides by 124. So 124. So this is 1. X times 1 is x. Now 1080 and 124, we could divide both sides by both numerator and denominator, I mean, by what quantity? So we multiply both by 4. So we could rewrite that into its simplest form. So 1080 divided by 4 is equal to 270, and 124 divided by 4 is equal to 31. So the value of your x now is 270 over 31. So that is your x. Now how about z? We find y when z is 82 and x is 4. So still we use this equation. Let us just erase some of our solution so we could make use of the spaces. Oh wait. Okay, let's delete these parts. Okay. So if you are confused, I already multiplied this. So that is z now is equal to 31 xy all over 15. So we solve for y. So again, by substitution, z is 82. So that would be 82 is equal to, so the constant of variation is 31. So we are going to solve for y. X is equal to 4. So that would be 4y all over 15. Again, we cross multiply. The denominator of this is 1. 1 times 31 times 4 times 1. So 31 times 4 times y is equal to 82 times 15. So let us multiply. What would be 31 times 4? So you have 31 multiplied to 4. That is 124, just like what we have a while ago. So that would be 124 times y is 124y is equal to 82 divide 15. I mean times 15 is 1230. The next step now is to divide both sides by 124. So this will be 1. Your y now is equal to 1230 all over 124. So we rewrite this into its simplest form. So what number can we use to divide the two? So let us first have to, let us check. So 1230 divided by 2 is equal to 615. Let me write it on this part. Y is equal to 615, while 124 when divided to 2 is 62. So our answer now is 615 over 62. Okay, another example, we have z varies jointly as x and y. So again, this is the first step. We write the equation. Z varies jointly, so that is k with x and y. Now, the next statement is that if z is 3, x is 3, and y is 15, we find z when x is 6 and 9. So let us start by getting the value of k, or the constant of variation. So by substitution, z is 3 is equal to k. Your x is 3 and your y is 15. So let me multiply this. 3 times 15, that is equal to 45. So times k is 45k. So 45k is equal to 3. Dividing both sides now by 45, so k would be isolated. So this is 1. So k now is equal to 3 over 45. But we can simplify this one, or we could rewrite 3 over 45. Let us divide both sides by, both numerator and denominator by 3. So we can rewrite it into its simplest form. 3 divided by 3 is, yes, that is 1. And 45 divided by 3 is 15. Okay, so the value of k now is 1 over 15. So if I will be substituting the value of k, z now using the original equation is equal to 1 over 15 xy, or multiplying now 1 to xy, that would simply be z is equal to xy over 15. So what is the next question? We have now the equation. We find z when x is 6 and y is 9. So we find z. So z now is equal to x is 6 and y is 9 all over 15. So aside from multiplying 6 times 9 and getting the product of 54, we could use cancellation of factors. Take note that 15 and 9 are divisible by 3. So if I divide it by 3, this will be 3, and this will be 15 divided by 3 is 5. So 6 times 3 now is 18 all over 5. So our answer is already on its simplest form. So z now is equal to 18 over 5. Another, c varies jointly as the square root of the product of x and y. So let me write the equation. Z is equal to k. We always have k. And that would be jointly with the square root of the product of x and y. So the square root of the product of x and y. Now, if z is 3 and x is 3 and y is 12, find the value of x when z is 6 and y is 8. So first, dito muna tayo. We substitute the given. That is 3. So we could solve for k. Square root of x is 3 and your y is 12. So we simplify. The product of 3 and 12 is equal to 36. So that would be 3 is equal to k times the square root of 36. And square root of 36 is 6. So 6 times k is 6k. Okay, 3. So we have to isolate k. I will be dividing both sides by 6. So your k now is equal to, by symmetric property, 3 over 6. Or when we rewrite that into its simplest form, k is equal to 1 over 2, or 1/2. So using now the value of k that we solved, we are going to have z is equal to So 1, any number multiplied to 1 is the same. So that would be xy all over 2, because that is 1/2. We no longer write 1. Okay, now we solve for x when z is 6 and y is 8. Let us substitute. So z is 6 is equal to the square root of. So we are going to solve for x, so that would still be x, and your y is 8, so times 8, so we multiply it by 8. Let me close that in a parenthesis all over 2. The next step is I'll get the cross product. So the denominator of that is 1. 6 times 2 is 12. And 1 times 2, this quantity is the same. So that would be square root of, let me multiply, x times 6 is 6x. So the square root of 6x. So to simplify, I will be squaring both sides of the equation so that we could eliminate the radical sign. So this will only be 6x. We remove the radical sign. 12 squared, so that would be 12 times 12 is equal to 144. So again, we are solving for x, so x should be isolated. Divide both sides by x. By 6. So that 6 divided by 6 is 1. And 144 divided by 6 is equal to 144 divided by 6 is 24. So the value of your x now is 24. Okay.